Let's have a look at how we could calculate energy efficiency. Remember that when we transfer energy from one form to another, we can't create it, we can't destroy it. So it all has to become something. And when we're looking at efficiency, we're looking at the proportion of useful energy compared to non-useful energy. So in this example here that we've seen before, you have a battery transferring its chemical potential energy into electrical energy as light and heat into the surroundings. And some of that is useful and some of it is not. And we can just depict that in this Sankey diagram here. So when we're looking at efficiency, we're measuring how good is a device at changing one form of energy into the useful form that we're looking at. And any device will never be 100% efficient. The more efficient it is, the less energy gets wasted. So an energy efficient light bulb, like the ones you usually see in houses today, is more efficient than a filament bulb because it wastes less energy. And it converts a greater proportion of the electrical energy supplied into light rather than heat. It's really important that we know how efficient our appliances are, and you'll have seen these labels on new appliances like fridges or washing machines, because then you can identify which appliance will cost you the least amount of money to run because they are more efficient. So it's not just about saving money, it's also about saving the planet, because if you use less electricity to power them, then you need to generate less electricity in fossil fuel power stations like coal-fired power stations. And this will mean that we have less pollution and therefore we can reduce the effects of climate change. So let's look how we can calculate energy efficiency. We use this formula where we take the useful energy output and we divide it by the total input energy. It's measured in joules. Energy is measured in joules, and we're going to end up with a number between 0 and 1 for our energy efficiency, and we usually convert that to a percentage by multiplying by 100 so that it's easy to compare one appliance to another. So there's the formula again with percentage efficiency at the beginning because we've multiplied by 100 at the end. So let's have a look at a worked example. We've got a bulb converting 200 joules of electrical energy into 10 joules of useful light energy. So the efficiency is 10 divided by 200, multiplied by 100 to convert it into a percentage. That gives us 5%. Let's have a look at this filament bulb. You can pause this video and work this out for yourself and then check if your answers are correct. So we have a filament bulb which is being supplied with 100 joules of electrical energy, converting 45 joules into light energy. So if you go through the steps, how much energy is wasted? In what form was it wasted? Heat. And what is the efficiency of this bulb? So if you got 45%, then you were correct. Let's do the same again for the efficiency of this radio. So you've got the data there. Work out the steps of how much was wasted, what form was the energy wasted, and how efficient is that radio. So pause the video, try and work this out for yourself, and then check the answers. If you got 32%, you are correct. Last one to try. Let's look at the energy efficiency of this television. Now you're going to practice some more by yourself. Collect the worksheet and give it a go.